Right. So application development starts from a problem statement. A problem statement is something which is given to you by business. A businesses are people who want a product to be created, right? And that usually mostly in the IT world, it's also called as a client. A client or customer comes with a business problem. He tells you that I want to have this kind of app created, which should have this feature, this functionalities, and this kind of behavior our app should have. So the first step, which a developer, because developer is now here, wants to understand those requirements, and then he want to capture those requirements, but he will not capture it entirely in words the same way what customers is saying. Maybe that is also one of the way of doing it. It can also go and record user journeys, but developer has different kind of diagrams at his disposal for him to capture those conversations, capture those requirements. So first thing first, what he really go and create is something called as use case diagram. Let me maybe create it, right something like this here. It's actually called as use case diagrams. Okay. Now use case diagrams are something which captures two things: the behavior and the functionalities. Sorry, behavior, or also called as functionalities, and actors. What are the different actors are there in the system? Okay, so for me, this is one actor, this is another actor. So I have one actor, it is a patient. Another actor I have, this is doctor. Maybe another actor could be maybe admin, right? Admin. Or another actor can be maybe let's say if you're also selling medicines there, perhaps another one who is supposed to have maybe the shop medicine for pharmaceutical person who sells medicines. So anyone who wishes to interact, or if let's say a client wants that these are the people who will interact with the system, you mention them as actors. Then you also go and mention different use cases, in the sense, what is the use case? Create appointment. This is one of the use case. What else? Register. What else? Login, because someone has to come and log in. Someone has to first come and register. Someone has to come and log in, and then someone has to go and create appointments. And then it goes on to say create appointment, then delete appointments. Okay, maybe someone is buying a medicine, so buy medicines. Okay, maybe diagnostics, right? So maybe diagnostics means some medical test someone has to do, right? There has a department there by which you can upload your things or download your reports and all those things. So there are different use case you have to define, right? And and then you have to mention the relationship between them. So a patient can do what? A patient can register. A patient can also log in. A patient can also go and create an appointment. Same thing goes with doctor, same thing. And admin can really do a lot of things. Admin can delete a doctor, admin can remove a patient. So maybe in the delete appointment, or maybe we say delete doctor. Simply we say let's say here delete appointment, and then here let's say we say delete doctor, right? Maybe deletion of a doctor can only be done by admin. Now all of them cannot do it. Okay, so these kind of diagram is called as, I'm just giving a brief of it. I am not really going to complete the whole thing entirely. Maybe I'll do that separately. But to explain you what is the first diagram which a developer creates when he hears the requirements from a client. This is called a use case diagram. And then he does more such diagrams. He creates some component diagrams, how how the database should be there, what kind of networking we have to create, what kind of network zones, what kind of different environments, and hell lot of diagram sets are actually being created. These all are called as architectural diagrams. So one example here is use case diagram. Another example is, I said, component diagram, then physical diagram, then something called a logical diagram. Okay, and then when you go deeper into the code, then you start creating your class diagrams, right? Then here's something called a sequence diagram. So there's no limit to what kind of diagram you can write to express the system. Okay, it's not that you have to really come up with all the diagrams for all the projects. Usually you choose what makes sense for you to capture the requirements correctly, as well as convey those requirements to your teammates. If your teammate is really big, different people responsible for doing different things, then you have to create all those diagrams so that you express what or where, what, and how a system should behave. Okay, so why I'm telling you this now is because we are in a process of creating an application, right? And you never go and start creating applications from the day one. Okay, day one t equal to 0, you don't do that. First, you need to really go and understand what requirements you are, what problem statement you are solving, what requirements gathering is, how you gather this whole phase is called as requirements gathering. So you need to understand what you need to create. You cannot create something which you don't understand, isn't it? So you need to know what exact system you are creating, and all that you do in a phase called as requirement gathering. In requirement gathering, you gather the requirements, but how do you write it? How do you express it? You express it using these diagrams. And the first thing here is not user case. Actually, it's supposed to be called use case. Okay, so you're supposed to create a use case diagrams which captures what are the basic fundamental top level view of what behavior your application is supposed to have. So create appointment, register, login, they are all are behavior are mostly expressed as verbs, right? Something which system does, a verb. So create appointment, system does. Registration, login, delete something, edit something, they all are different behaviors, things which a system can do. And these are nouns. Actors are usually nouns, people who will interact with that system. Okay. uh, I also had few more diagram. Maybe I'll show you this one. This one is what I was a small glimpse of how a component diagram may look like. Okay, so component diagram mentions here what kind of components your system would have. Okay, so here, for example, I am saying I'm going to have a UI component, and then I will divide my system into multiple small microservices, small services for each representing each functionality or verb. So if you see in the previous diagram, I had use case diagrams, I had patient, create appointment, register, login. These all were what? These were patient, all these were actors, and were my behaviors. And what I've done here is I'm trying to express all of these behaviors as a separate service. And then here I'm trying to express what kind of components I would have. So I'm simply saying I will have a UI, then I will have something called as API gateway. API gateway is a is an infrastructure component which makes sure that your backend services are decoupled with the UI. So UI do not directly is supposed to be calling the backend APIs directly. Rather, they will call API. API gateway will actually go and route those requests to different APIs. This is how you decouple the front end with the back end. API gateways understand this as a router which knows when a request comes from a client, which is a UI, right? UI browser. UI understand this UI as a browser. When browser try to call an backend API, it doesn't in a live production environment. Local development, we still can do direct calling, but in actual live production environment, the right architecture, as per right architecture principle, you should have to have something called an API gateway, also called as reverse proxy, and in very simplistic term called as simple plain router, which routes your request coming from here to here. So I'm expressing that when I'm going to have this fully functional application, I'm supposed to have these different APIs. okay, representing different behavior of my application, and then API gateway, and then there'll be UI, and then backend I will have, these databases for each API. So I'm actually creating a polyglot system. This is called as polyglot system, where I have separate APIs. Every API has its own database. And this brings some more challenges in the microservice architecture world, but we are not going to go into those details at the moment. Okay, so roughly this is component diagram. Okay, so I'm saying I may have one approach like this, or I may have also one approach like this. That means each service will have separate databases, or I can have each service has using just one database. Okay, so this is just an approach I'm trying to propose to people. What is the right way of doing it, etc., etc. I'm going to go for this application development, which we are going actually doing. I'm going to go this way. Okay, then you will have something called as sequence diagram, where you mention how the flow of information will happen. What will happen first, what will happen next. I'm saying as a user, I'm a patient. UI will say enter ID submitted, and then UI will say show welcome message, and then they will show my profile, and then UI will go and call this specific endpoint patient ID. Patient API will go and query the database will then go and return patient details, and then it will be returned as a JSON, and then UI will display it as an HTML. So this is just one user story where client is opening, client in the sense actor, which is this one, is opening the browser, and then browser is asking him to do something. That is login. The UI, the patient or actor will log in. Then the UI will show the welcome message, and then the actor or patient will go and ask for his profile, and then profile will go and get queried in the database returns, and then patient API returns it back to the UI will actually go and show it as a HTML. Okay, so what are all these? These are just a way of expressing what is to be created. So before we actually an API development or UI development actually starts, these diagrams first are created. They're created first, and only once they are created, discussed, reviewed, accepted, showed to client agrees. Once all that is discussed and signed off from different people, only then you start creating an application. Okay, this is just one of the approach by which people do it. There are different approaches to it. People may also say don't spend too much time in documentation, just start developing it. That also may work for some startup culture, but more or less in an enterprise setup, enterprise companies and projects, people usually still go old school, where they go and create these diagrams first, which actually make a lot of sense. I am completely favor of these diagrams to be created first, so that all the people, because in big enterprise setup, it's not only you, two, three people who develops this. If you have a small team of two, three developers, then maybe these diagrams may not make sense, because you will end up losing some time creating them. But in a big setup, big company, you will have different teams, maybe 10, 15, 20, 100, maybe 50, 100 people working on it. And so it's not easy for you to just start creating. You have to come up with things so that you tell to everyone and discuss it. Everyone understands, raise comments, debate on it, and then once you finalize it, then you actually start it. Okay, so just to summarize on this part, you always start with the requirement gathering thing. In the requirement gathering, you go and first create these documentations, these diagrams. So if you always starts with use case diagrams, then you go and create some component diagrams, some sequence diagrams. Then there's also something called as user stories. So you write user stories, user journeys, as if the actual application, or as if actual client has actually narrated you things. For example, customer comes in and says, okay, I want this to be done this way. So you actually capture it the same way. I'll show you the example later. It's something called as Gherkin syntax that we'll see later. But people also go and write those statements to express the requirement. So that is all comes under requirement gathering phase. Okay. Any questions in what I just said? This is just first part of my today's agenda. about requirements gathering, because now we are in the process of creating an application, and the first step is always requirements gathering and documenting it. Okay, no question, I'll move forward. So this is the first part. Second part is, once my things are done, then I mean, once my documentations are done, and then I'm kind of a bit convinced, yeah, this is how I'm supposed to be creating, then I will start creating my application, right? So here I have two things to create. One is a UI component, and then I have different APIs which I'm supposed to be creating, right? What I've done is, to speed up the session, I have actually already created the basic structure, basic skeleton of all the three. Of course, they are very, very minimalist. That means they are still using an S2 database. They're not using these databases. They're using S2 database, and then they have all the endpoints necessary, which we need, and they are supposed to be interacting with each other. Those functionalities I have not implemented. I have just come up with a basic structure which works. So that's the first step I have done. So that is what I'm going to show next. So this is what I have. This is a Doctor Everywhere reference app. It's the new repository, a new project I have created. And in this one, I have created this as a module project in Maven. So in Maven, there is a concept called as modules. Module simply means you have a parent project under which you have sub modules. And the way to express that is, you create a parent POM. So I have parent pom.xml like this. And then here I mentioned parent, my group IDs and artifact ID, packaging, all those things like this. In the packaging, I have to mention POM. This makes sure that I have my project is the multi-module project. And under modules, I have these three things: Doctor API, Patient API, Appointments API. Before this, how I was doing was, I was having a separate repository for each API. If you remember, I created one API called as Employee Spring Boot Reference API, which we were actually working on to learn all the Spring Boot related things. There, I had just one repository. That repository had just one API, and that is also a very good approach, wherein one Git repository contains just one project. But for learning purposes, or in many cases, it also makes sense to keep things at one place for easy maintenance and for easy development. And that's the reason I chose Maven multi-module, and I've kept all of them in a single repository called as Doctor Everywhere Reference App. This is also called as monorepo. Mono means single, one repo means repository, of course. So one single repository, I have multiple APIs. So if you see here, I have Doctor Everywhere Reference App. I have pom.xml file. Then I have modules here, and then I have packaging as POM. And inside this, I have three more folders, and all of them are actually a separate Maven project in their own right. Okay, so I have Appointments API. It has its POM, child pom.xml. This is pom.xml, another one. This is pom.xml for Patient API. And if you notice, there is nothing much mentioned here except the parent, and the parent here is coming from here. So all the dependencies and everything I define just at one place, and they all will be cascaded deep inside the child modules. Okay, all I'm mentioning here is artifact ID, and that's it. Okay, so this is a multi-module project. I have kept this here. If I show you, so I have kept this here. Okay, so you see this is my repository path, and I have three repositories here. Sorry, three separate modules and projects here. Okay, then if I go back to my idea, my IntelliJ, sorry, and here I have Appointments API, Doctor API, and Patient API. So what I'm really trying to create here, right? If I go back to my diagram again, which is this one, I'm trying to create these three components. So patient API, service API, doctor service API, appointment service API. And what I'm trying to do is I want to create a functional, I want to implement the functionality of appointment booking. So for appointment booking, I need what? I need to book an appointment for two people, because for appointment, you need two people. One is patient, one is doctor. So I want to book an appointment between patient and doctor at a specific time, at a specific date, and a specific venue, whatever clinic that may be, right? So this is my requirement. So I created these three separate APIs and I've kept them in the single repository here, right? So for example, in the case of appointments API, I have this main, I have this inside Java, I have these necessary 5 things. So you know by now, I think you all know, when you create a Spring Boot API, you need 4 things. First is the appointment app itself, which is marked as Spring Boot application. Then you would need controller, which defines the service endpoints, okay, like these. Then you have the service, which defines the business logic of your operations, which are supposed to be performed by your controller. And then you have a repository. Repository represents your database connection. Okay. Apart from these 4, there's also one thing called as entity. Entity is always present inside an API, which represents what is it which you want to alter or create or delete or fetch, right? So any API which you go and create in Spring Boot, you will always find this endpoint, okay? Because when you create this diagram, right? Here I'm saying patient service API, or even if I go and check my use case diagrams, right? These are what? These are verbs, right? A verb is what? Verb does something to something. Okay, so here, for example, I'm creating an appointment. So what I'm creating is an appointment, right? What I'm going to delete is also an appointment. So appointment becomes an entity here. Same case for patient, same case for doctor. So I want to create what? So creation is a verb, but what to create here? Doctor is what I have to create, an entity called as doctor. Same thing was happening when we were working with the employee Spring Boot API. Employee was an entity. So here, if you go back, appointment is my entity, and I have tagged this at the top of it. I have tagged it as entity, right? And then I've created some attributes. I'm saying ID. ID is a unique key for each and every appointment I go and create. And I put generated value as automatic. So it will be automatically generated. Then I have booking date and time, because appointment require booking date and time. Appointment date and time. So a booking is when the appointment was booked, and appointment date time is when is the appointment is for. And then patient name, who is the patient, doctor name, who is the doctor, and venue. So these are the basic, very minimum attributes I need to have. Then I am saying repository, no rocket science here. Simple interface, extending with JPA repository, coming from Spring Framework directly. And this let me link the database with the queries. So queries represented as methods, and when I call those methods, they translates into a query, and then database operations are performed. And then service, you know what it is. It's simple. It's just way of abstracting your business logic within the service, and the tag for it is @service. And then the resources all I have is application.yml. Here if you see, I'm still using H2 database. It's an embedded database, which actually still mean that I am using a polyglot system, because now for each of these each of these service, I have a separate database. So separate database for this one. This is in this case H2 database. This is also H2 database. This is also H2 database. They're not a single database. They are separate, only serving that specific API and not this model. And we will never be doing this model, because this model has some drawbacks. Okay, so it's because we are learning different patterns which we have in microservice architecture, where and the pattern here specifically is that for each service we are having its separate database to completely decouple, completely make that service independent of everyone. Because if, for example, I continue to use the same database for all, I'm still creating a dependency of some sort, and I don't want to create a dependency for my new microservice architecture. So I'm trying to create uh, a decoupled system where even the database is not shared. Okay, and guys, give me a minute. Okay, right, sorry. So now we have separate databases for each API. One is your appointments API. I've explained that, nothing different here. These two also are very similar to what the way appointments API is being built. So I go to main. In the main, I have exactly the same thing. So I have controller, I have Doctor app, I have Doctor entity, I have Doctor service, and I have Doctor repository. Okay, and same thing goes with my patient. Okay, say exactly same pattern I have here. Now, what's not yet implemented is some calling between these APIs. So, for example, if I were to go to my appointment API, okay, if I go and let's say just run this one. So, if I say run, so now my appointments API runs, and then I say doctor app also run, and I say patient API also run. Okay, and I will go and run my patient API also. And all of them I want to run on a separate port. So this one runs on 8082, and then this one runs on 8083, and this one actually runs on 8081, if I'm not very wrong. Yeah, and now I go here, I simply say localhost 8081. This one is for appointment, and same goes here 8082. This one should be for patient. Yes, and this one is for doctor. So I have now three APIs up and running, serving the requests. Okay. Now what you're seeing right now and what you have seen so far when we are learning Spring Boot is the uh, is only the Swagger document, right? So when you create an API, all you see is a Swagger document. But essentially, these Swagger is only for document what your API can actually do, right? Essentially they are being actually supposed to be called by an user interface which is not there at the moment, and that user interface we are going to be creating using React, right? And that is also something which we do not today, but we'll do that later, maybe in the next one, when we actually start implementing our pages also. And the way we design pages is, or before we actually go and design pages, is is another sort of diagram called as wireframe. Okay, so wireframe document is what? Wireframe simply means how a system would look like from a user interface point of view. Okay, so these kind of things, these kind of, let's call it a diagram, it's because it's still a diagram. A wireframe is also it's kind of diagram, but from a user end perspective, user interface perspective, where you define how and what kind of elements, what kind of message, um, what should be the layout of your application, all those things. So here, this is an example of a wireframe. So I'm saying the first page would look like this, and then if someone clicks on I'm patient, he will be entered with okay, enter ID and login, and then once he logins, we have validated. Right now, whatever APIs we have created, there's no functionality of registration and login. If you see, I have this use case diagram. I have not implemented this and this. I have implemented maybe this, maybe this, maybe this, but not these two. Okay, so that part I have not implemented, but in the wireframe, I ought to mention what should be the flow of information, how the user journey will happen. Okay, so I will first go and validate. Once it's validated, and then someone clicks on my profile, it will go and call the patient API. Patient results will be returned, and then things will be. And if someone go and clicks on find a doctor, the list of doctors will return. So there will be a call. Someone clicks on find a doctor, an API call will happen automatically by browser to doctor API, and doctor API will return all the results of all the doctors it has, and it will go and display it here. And if someone goes and click on book, the moment someone clicks on book, then it will ask for select the slot, select date, select time, and if booking is success, if slot is free. So there's few checks also I'm doing, if you see. So after I click on book, it will go and check whether the slot is free or not. If slot is free, how do you know that? In the appointment API will check patient ID, doctor ID, date, and time. So based on these four parameters, it will check in its database, is there existing appointment for this doctor at this point at this clinic? If the answer comes as yes, then it will say appointment failed because booking cannot happen because there is already existing appointment for that. And what if it is not, if it is available, then booking successful. The slot not available, error message when there is nothing. If there is a specific appointment is there for the doctor, if not, then booking successful. Okay, and this one is to click on my bookings. So we are also supposed to go and see how many operations, how many appointments he has. Okay, so he the doctor comes in, clicks on my bookings, and then he will see, okay, I have these many bookings, these many people are there, and then if whatever booking is completed, it will be marked as completed. If it is not completed, then it will mark as upcoming, or he can also go and cancel it from there. That I cannot make it. So this is a view, right? This is how a user interface are created um, from the top view, because this is what your client sees. This is what your customer who is going to come to your application sees. And this is something very important. Without this, you never go and start creating your application. Okay, and for UI, you need to provide APIs to UI, right? So these Swagger document which you see here, you give these to your front end developers. In our case, because when you do this in a full stack way, you are the one who creates the front end, you are the one who creates the back end. So fine, but whatever API you are creating, if you want someone to use it, you have to give a Swagger document like this, and based on this, the front end developer will know how to make those API calls, what kind of parameters has to be passed, how the schema of the request as well as response would be. All that information is actually present inside your Swagger document, something like this here. Okay, so that is basically the diagram for the front end, where you create something called as wireframe. Okay, I have now these three APIs up and running. Okay, here another thing which we want to understand and learn is how will you deliver, how will you package your APIs, and where will these APIs would actually go and run. Okay, because when I run this API, I am running this on my local machine. Okay, but the actual customer is not going to be opening it from a local machine, right? You have to deploy it somewhere. Same thing goes with your user interface. When you create using React, you create it on your local machine, which is just local. For local development, fine, but you have to package it and you have to run it someplace, somewhere. Okay. Now there are different approaches to that. In the world of microservices, uh, what you get out of an API or a UI is a distributable. In the case of an API, you create when you compile this, you get something called as a jar file. This is your jar file which gets created when you run Maven clean package. You get app.jar, a jar file which contains your application code, the whole API, and you can run it somewhere. Okay. Now there is also a concept which we learned in the previous sessions. It's called as containerization or Dockerization, where what you do is you 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 wrap your application around operating system, and the whole thing, operating system plus application, you bundle it and you call it as Docker image. And that Docker image, you put it in a registry called as image registry, and from there it could be deployed anywhere. Deploy in the sense a place where your application would run. So it could be a centralized server running and something called as orchestration or Kubernetes. Kubernetes is a software which we see later, but it's a place where you actually run your containers. Okay. Right now, everything looks smooth because you're running it in local machine. You click on a run, you have IntelliJ, you run it, press on a run button, it runs on your machine. But in a real production environment, this is not how it would work, because your application has to be accessed or accessible by an end customer who is sitting somewhere else in his own system. It has to be connected via network, and there has to be a server, and the server there has to be a container which is your application, and then it should take the request and give the response back. So for all that dance to work, you need to think about how you will package, how you will um, package and distribute your application. Okay. And from there comes the concept of Dockerization and containerization. We have done one session, rather two sessions, on containerization and Docker. What is Docker, how Docker works, what is containerization, how containerization works. I demonstrated few concepts there called as DockerFile, and how you will build the image, and then how you will run the image on a local, and how you will go and run it on a server. I showed you a Docker playground, I think sometime back in December. Okay, so I'm going to use the same concepts. Okay, now my application will have something called as a Docker file. For example, I have my application I have actually one application. Within it I have three modules, right? Each module represents separate applications, so I actually have a Docker file for all these all the three services, separate services. For Dockerizing an application, there are different ways. So there is something called as Google GIB, which is a Maven plugin. So I'm not going in that in using I'm not going to build my images using that approach. So I will be using something called as DockerFile approach, where I have a Docker file something like this. Okay, and the instructions here are quite simple. If you see, I'm saying these are the arguments, fine, just environment variables of some sort. Here I'm saying I want to use a Maven, a base image. For every Docker file, you will always have something called as base image, and that base image contains the basic things which is required to build, or which is required to run my application. And I'm saying I want to use an image which has Maven and which is a JDK having 11 version. Okay, and I'm actually copying my things inside. So I'm saying copy form.xml file, which is this one, copy this from here, from my local, to the build context here for Docker build context. Then I'm saying copy the source, which is this one. Nothing is inside this, but still I'm saying source, copy this. And then I'm copying the individual folders also. And then I'm running my Maven commands, and this will download the dependencies and build my jars. So inside this, I will have my jars also being created, targets. Okay, and then I'm going to run another stage. So this is called as multi-stage in Dockerfile. See, I'm not expecting you guys to understand everything from this one, but I've actually explained all this in the previous sessions. To understand the intricacies of how Docker works, how Docker layer operates over each other, and how to make my Docker image more leaner. This is a sample file which I'm showing you right now. Okay, and this is a very good way, a very good, well written Docker file, built for bringing a leaner and efficient image. Okay, and how you create it is like this. So if let's say you don't understand each and every line of this file, fine, you can still go and copy and paste it, and this will still run, and it is just fine for now. So you don't have to learn each and every, because you do not uh, go and write each of these lines by your own hand. You always go and find the reference and copy it and paste it and make it work. Okay, so if you however, the lines present here is very, very simple. These are just commands, these are just arguments. Okay, okay, so now this is your first stage. Okay, uh, and then this will build your application, and then this one is the one which is actually going to be present inside your final image, and this uses Maven toolchain cache, which is this one, and it will copy the results of what happened here from here to the another folder created inside build target. And then here it's simply saying this is my environment variable, and the entry point for this is java jar app jar. Okay, so what is really happening is, after this application is being, or this image is being executed, the moment this image is being executed, uh, the app here or is actually being triggered. So when you run an image, it becomes, or it then it's not, it's actually then called as container, right? So when you, this is the process which you see here is Dockerfile. So when you say Docker build, you are building an image. When you say Docker run, you are running the image. And when you run the image, it becomes a container. And before an image can be run, successfully executed, run, it has to be have an entry point, a command for an image to know what is to be spinned up, and once container is up, what command I have to run. So here I'm simply saying run java jar app jar. App jar is what? The actual application. And when this runs inside a container, the API starts working. Okay, so this demonstration I have done in my previous one, where I was explaining Dockerization of employee Spring Boot API, and that is what I have shown there. So same thing I am trying to do here. So I have separate Docker files created for separate applications. For three API I have three separate Docker files here, and I'm saying build Docker API target. So here I'm copying everything, building everything, but I'm only copying for example, this is dockerfile.docker API. I'm only copying the build Docker API to target app.jar, and only building that specific API as a part of this build. Okay, so I have three separate Docker file for my three separate APIs. Okay. All right. Then last thing which I want to show is something called as Docker Compose. So Docker Compose is a simpler way of how you will bring up your whole application together. Okay. So here I am simply saying I have a Docker Compose file, and I want to build this using this Docker file. So first the image will be, first my application will be built by normal Docker build command, which I don't have to explicitly call. The Docker Compose file can actually build it, and when it's built, it will go and start my application. All the three APIs will just come up automatically. So here, if you see, to create my application, I have to bring all these three applications together. I have to go to each of this one after another, and he run it from here. So I run it here, and then run there, and then run the other API. But when I do this using Docker and Docker Compose file, Docker build happens. First, Docker images are created, and then Docker containers are spinned up, and they are also connected to each other using Docker network. So that part I will explain maybe in the next one, because first I want you guys to reach to this point at least, so that we don't have too much, I don't give you too much or overwhelm you with too much information. So Docker part, I'll give you some introduction of what's going to happen, what we are going to do, and that we will, the experiment part, the working part, we will actually do in the next one. But I will be completing this piece of Dockerizing and making sure that it runs using Docker Compose, and I will complete this and I will publish it back to my repository, which is here, so that you will have the working application. All three applications works using Docker Compose up. And the way you will run it later is simply you go back here, you will say Docker compose, and you simply say up, something like this. Okay, this may not work at the moment because there is some issues at the moment with this one. I'm going to fix this, and your application will then start running. Okay, any questions so far?